Today our lab is lab number 11. In lab number 11 we are performing the lab of tank filling using fatigue PLC. This is the lab number unit number 8, but today is our lab number 11. So we are performing the lab of tank filling control. This is the tank filling control lab. After performing this lab, the student will be able to perform the tank filling operation by using fatigue PLC. And what are the objective of this lab? The objective of this lab is understanding the operating principle of tanking filling control the tank filling system manually. Mean we have to understand the operating principle of tank filling control, how to what is the principle of tank filling control, and the fillings, how to control the filling system manually. So this is the objective of this lab, that how to principle of filling control and filling the tank manually. Okay, this is the objective of our lab. So we have to use it tank filling control is our lab, and objectives are objectives are principle of tank filling and second objective is to control the operation of tank filling manually. These are the objectives. In this lab we are using inputs. The inputs we are using inputs. One input is x2, other one is x2, x3, and the next one is x4. This is the inputs. Okay, we are defining inputs under the input option. x4, x5, and what are the output? The output is y1 is the output. So for getting the output y1 by using these four inputs, we are using registered. By operating this output by using these input, we are using some registers. Registers are used for storing operation. Okay, how to store and for storing purposes. What type of register we are, what is the name of the register we are using? The register is R0 and second register is R1. These two registers are used for the storing purpose, and we are using relay we are using a relay. The relay we are using are M0, M1, M2, M3. These are the relays which we are using. This relay, the working of this relay is to energize it. When the tank 1 is empty, or tank 2 is empty, or tank 2 is full, or tank 1 is full, these relay will be energized. Okay, these are used for energizing purposes. And the relay use for the internal relay, which is 1921 and 1924. M1924. These two relays are used for clock pulse, and the 21 is used for clock pulse, and this is used for scanning purpose. Okay, this is used for 0.1 second clock pulse, and this is used for first scan. These are the relay which are used to energize. This relay M0 is energized when tank number 1 is full. M0 is used when tank 1 is full. And what is the purpose of M1? M1 is used to energize when tank 1 is empty. So this M2 is used. This M2 is used to energize when tank 2 is full, and M3 is used, and this M3 is energized when tank 2 is empty. Okay, these are the internal relays which are going to be energized when tank 1 is full. It energizes M0. When tank 2 is full, the relay used for energizes M2. When tank 1 is empty, the relay used for energizing is M1. When tank 2 is empty, M3 relay is used for energizing. Okay, these two what is the purpose of this relay R0 and R1? The purpose of R0 is the height of the liquid in tank number 1. Show the height of liquid in tank number 1. This R1 and this R1 is used to show the height of liquid in tank number 2. Okay, these are used for the identification of height of liquid in tank 1 and tank 2. These X2 is used for input of tank number 1 for controlling liquid supply. Used for input valve for controlling liquid supply to tank number 1. This X4 is used for input of liquid supply to tank number 2. This X3 is used for controlling liquid drain in tank number 1. For controlling liquid drain in tank number 1, and this X5 is used for controlling liquid drain in tank number 2. So as you know that we are dealing with the tank filling control. So it is understood the tank is if you are initially on the motor and there is nothing in the tank, so the tank is empty. So the tank is empty. If we are using two tank 1 and tank 2, if tank 1 is empty, the relay used for energizing is M0 M1. And if initially the tank 2 is empty and there is no water in the tank, so the relay used for energize is M3. This relay is used for energizing purpose. This relay M1 is used for initially it is empty, so relay M1 is used for energizing purpose. When tank 2 is empty, relay M3 is used for energizing purpose. Now we have to when we on the input, when we on the valve, so by using to on the valve, X2 is used to on the liquid supply for tank number 1, and X4 is used for to on the supply of liquid into tank number 2. Okay, now the supply is open for tank number 1 and tank number 2. Now when it range to some when you are using when it is used for domestic purpose or commercial purposes, so the X3 valve will show the liquid drain, how many liquid will be drained from the tank. So this is the consumption. X3 is used for the consumption of tank number 1, and X4 is used for the consumption of X5 is used for the consumption of liquid from tank number 2. This is used for consumption purpose. While you on the motor and liquid is supplied uh, from ground to your tank number 1 and from ground to tank number 2, and there is also usage of water from tank number 1, which is controlled by X3, and also usage of water by using tank number 2 from input valve X5. If you are using your water and for your usage, and at that time the water level will be will move to the full will move toward the full mark, and your tank 1 is full, so the relay used to energize is M0. And when this same occur in the tank 2, tank 2, the relay M2 is used for energize purpose. Okay, this is the tank filling control. So we have to and this Y1 is the output. this y1 is in output when two tanks are empty. Two tanks, tank 1 and tank 2 are empty. If both of them are empty, the y1 output will be on by identification of buzzer on. Now we have to simulate this lab by using ladder diagram. The test bed software is WinPro ladder, and this is the test bed, and there's no hardware PLC, but the format is the WinPro ladder is used for static PLC. Okay, now we have to start WinPro ladder. Okay, now start new project. This is a new project. Click on the model number FBS24MC. Okay. This is your new project, and we have to start from rung number N000. Use the relay M1924 for the first scan purpose, and it is attached to the move operator. The move operator source the value of source is 0 and the value of destination is R0. So on first scan of 1924, it will move the value of 0 into register number R0. As you know, the R0 is used for the purpose of height of liquid in tank number 1. So for the initially we are again using movement operator, and store the value as a source 0, and we are using R1 because these two are used for the height of liquid in tank number 1 and tank number 2. Now this is connecting to the okay. So initially initially first we have to use the M1924 internal relay for the scanning purposes, and we have to scan our ladder diagram, and we have to initialize the tank number 1 and tank number 2 by using register R0 and R1. Both of these R0 and R1 are initialized by using a value of 0. Now we have to move toward rung number 1. So we on X1, which is used as an input for tank number 1 for controlling liquid supply. This X1 is used for controlling the liquid supply in tank number 1. This X1, when it is on, it is connected to the internal relay M1921 for the for 0.1 second clock pulse, and in series we are using M0. which is in off state. So M naught is the used for to energize. It is M naught is energized when tank 1 is full. So we are using these two as a function operator for the operator of addition. In SA we are using R0 as a initial value of tank number 1 and SB for the 1 for increment the value in increment the value in the liquid present in the tank number 1, and D is the destination for R0. So we have to increment the value in R0, the value of R0. So the value of R0 will increase from R0 to R0 plus 1, and it is stored in R0. In rung number 2, we are using operator 17 for comparison purpose, for as a comparator. We are using 17 operator as a comparator. It will compare the value of R0 with the SB register, whose value is 300. It will compare the value of R0 with 300. If the value of R0 is 300, it will on the or energize the motor M0. So it will energize the motor M0. So what is the M0? If we have to go back to this one, first it will scan these two value of initial liquid value in tank number 1 and tank number 2, and then it will on the X1, which is used for the liquid supply to tank number 1, and at the same time the timer is on by using a relay 1921, and it will initially off. M0 is initially off, and it will add the addition operation to register R0, and it will increment the value of R0 to +1, though this value is stored in destination, which is R0 plus 1. Then this value is increment, and for comparator we are using 300. If this value approaches to 300 and A equal to B, and the value of the value of R0 is 300, so it will energize the M0. What is the M0? M0 is the relay when tank 1 is full. When tank 1 is full, it will compare the value 300, 1, 2, 3, 4, 5 up to 300. When it will move toward the storage value in R0 is 300, it will energize the M0 that the tank 1 is full. So now we have to move toward the rung 3. In rung 3 we are using X3 as an input. X3 is used for the purpose of drain liquid from tank number 1. This X1 is on, and it will connect it in series with the internal relay M1922, and this relay is connected to the M1. M1 is used to energize when tank 1 is empty. So this is connected to the again with the it is again connected with the function using 112 number, which is a subtraction, which is used as a subtraction. So we have to use source as a r0, and we have to decrement the value 1, and the r0 minus 1 value is stored in destination by using value of r0. So when x3, when we come to know that it is empty, we have know is it empty or not. The value stored in the r, if it is full, or the value of r0 is 300, and when it will decrement from r0, mean 20 to 99, 298, 200, 150, 150, 100, 50, and then when it is 0, so this will be a decrement value. This decrement value will be stored, this decrement is stored in the destination register D by using name R0. So to confirm it, there is the value, is the R0 value is 0. If it is 0, if it is 0, it means the tank 1 is empty, and we will on the motor M1. So we have to use the move function 8. No, for move we have to it is not move function. It is move not function, it is a comparator function. We are using comparator for comparison purpose. So we have to compare R0. If the value of the height of the liquid represented by R0 is 0, if it is 0, it will, if A equal to B, then it will energize the internal relay, which is M1, which is M1. So when the value of water, when the liquid water, then when the liquid water is decrement from 300 up to 0, and if the value of R0 is equal to 0, then it will energize the motor M1. It will use, the M1 is used for the empty purpose of tank 1. So we are using for LED purpose, for indicator purpose, we are using M0, and it is used for as a output Y6. And what is Y6? Y6 is the indicator for tank 1 in full condition, and we have to on the M1 relay. We have to, if M1 relay is on, so it will give you the output indicator Y7 as show that the tank 1 is empty. So Y6 is used for the purpose of, so Y6 will show you, so Y6 will show you tank number 1 is full, and Y7 will show you the tank number 1 is empty. Now we have to move toward rung number 7, and we are using X4 for controlling the input to tank number 2 for liquid supply in tank number 2. This X4 is used in series with internal relay 1921 with the off relay of M3, which is then used for the function addition function, and we are using the R1, which is the R1 is used for the storage of liquid height in tank number 2, and it will add the value 1 and restore in D register by using name R1. So it will it will add 1, and the value will be added up to 300 count, if the value compare, if S1 is SA, if SA value R1 is equal to 300, so it will energize the relay, and that relay is M2, which is used to show you that tank number 2 liquid is above the limit. So it will give you that the tank number 2 is full. So the energizing condition of M2 is when the tank 2 is full. So we are using X5 as an input for controlling the drain water, the drainage of liquid from tank number 2. So X5 is on with the M1921 in on condition with the off relay M3, which is used for comparison purpose, for the subtraction purpose. So for subtraction we are using R1, which is the height of liquid in tank number 2, and it will be decrement by value 1, which is stored as a R1 minus 1 in R1. In rung number 10, the comparator is used for operation of, for the identification of is R1 is 0 or not. If it is 0, then it will energize the output relay M3. It means that the tank 2 is empty. So for indicator we are using relay M2, which is when on it will blink the LED of Y8. These are the LED Y8 which will show the tank 2 is full, and which will show you the tank tank 2 is full, tank number 2 is full. So we are using M3 relay. When M3 is on, it means that the Y9 indicator will on. Y9 indicator will show you that the tank number 2 is empty. So these are the conditions when any one of the tank is the condition of the tank, if any one tank is empty or filled. So now we have to have one more condition when both of the tank are empty. When M1 tank is on, it means the tank number 1 is empty, and M3 is on, it means both of the tank are empty. So it will show you by indication of Y1. So Y1 will give you the indication of Y1 will give you the indication by using on the buzzer on when both tank are empty. When both tank are empty, it will give you the buzzer. So we have to include two more output. One is the Y6, Y7, Y6, Y7, Y8 and Y9. So Y6 is used for indicator LED when tank number 1 is full. The Y7 is the tank indicator, tank number 1 indicator when it is empty. So these LED will be on when tank 1 is empty. When Y8 is used when tank number 2 is full, and indicator LED Y9 is used when tank 2 is empty. So this is our lab for tank filling control, and these are total input. This is a readme file for usage of this ladder diagram. So now we have to simulate it. We have to simulate it, and we have to we have to use the status page. In status page we are using the output. And what are the outputs? The outputs are Y6, Y7, Y8, Y9, inputs are X2, X2, X3, X4, X5, and the value of register R0, R1, and the relay M0, M1, M2, M3. Now we have to monitor this. Okay, now we have to first initially we have to off this. We have to off this relay initially. Off this relay initially. It is already off. We have to negate this. Okay, sorry. Just only those relay will be red which one when any one of this is off condition. Okay, so we have to run our PLC. So we have to on this. On X1 it will calculate from R0 to 29. You have to here R0 45, 46, 48, 49. When it will be 300 it will on the M0. Okay, when it is 300 it will on the M0. 104, 106, 118, 23, 29, 30, 34, 30, 41, 48, 50. When A equal to B, when R0 equal to 300, it will on the M0. So it means the tank 1 is filled from liquid water. So it will move toward the 250. Okay, it M0 is on. It means the tank 1 is on. Now we have to on the tank number 2. So we have to on tank number 2. For tank number 2 we have to use one button. We have to on it. Now when it is on, okay, first we have to discuss is when tank number 1 is empty or not. We have to then use this tank 1. We want to empty tank 1, so we will on the X3 switch. So X3 switch will be on, so the value of R0 will be decrement from 300. When it will reach toward the 0, it will on the M1. This is 295, 296, 295, 94, 93, so we have to on the same time we have to on this X5 also. So this indication Y9 show that tank 2 is empty. It will show the tank 2 is empty. When tank 2 is empty, we have to on the X4. So we have to again restart it. So we have to start it. So this page we have to again run it. So we have to initially off X3. Okay, we have to initially off X3. We have just on X1 and we have to off this X4 also. Okay, we have to off X5 also. Okay, first we have to on the we have to fill the we have to off also. First we have to uh, 0 this value, so our register value is 0. Okay, now we have to run we have to stop the simulation and then again run it. So initially x1 is 0, so it is we have to on it, so we have on this one, so it will increase the value up to 300. If its value reach to the 300, it will on the M0. As M0 is on, it means the tank 1, the liquid in tank 1, the tank 1 is filled with liquid water. So now this one is on, it means the tank 1 is filled with water. Okay, now we have to find it if it is empty or not. We have to on x3 also, so it will decrement the value. It will decrement the value of R0. So we have to stop it, and we have to use the value of we have to stop it, and we have to use the value in R0 as a 0. Okay, now it is value 0, so we have to again run it. Okay, we have to move toward this next x4. We have to on x4. When it is on and we have to run the PLC, it means the tank 2 is now when the tank 2 is filled, so it will on the relay M2. So the value of R1 is moving toward 300. When it will struck 300, it will on the M2. What it mean? When M2 is on, it means the Y8 is on, the tank 2 is full. Okay, look into it. The value is 210, 213, 15. When it moves toward, when it will reach toward the 300, it will on the relay M2, and at the same time it will on the Y8. So it will reach toward the 300, so it will on the Y8. So the Y8 is now on. So Y8 is now on. Okay. Now we have to we have to use X5 is on. When X5 is on, it means the value will be decrement, and it will when it will be decrement when it will decrement, going to run it again. We have to off it, and then we have to on this. It will decrement one value, and then we have to off it. Okay, its value will be decrement. If its value will so its value 155 on this it is. If it is 300, it will on the M0. Now M0 will be on. M0 on, it means the tank 1 is on, tank 1 is on. It will be indicated by indicator LED Y6. So Y6 is on. Okay. Now we have to on the X3. Now we have on X3. We have on X3 and off X1. Now it will decrement the value from 300. When it will reach toward the 0, M1 will be on. If M1 is on, it means the Y7 is on. If Y7 is on, it means the tank 1 is empty. Now it will decrement. This value decrement, it will reach toward 65, 64, now 50, now 20. When it will reach toward the 0, it will on the M1. Now it is 0, it will on the M1. If M1 is on, it means the Y7 is on. Y7 is on, it means the tank 1 is now empty. Now we have to move toward tank number 2. So we have to off tank 4, we have to off first tank 4, and now we have to on it. But we have to off this one. Okay, now we have to increase the input supply value, so input supply water into tank number 2. When it will move toward the 300, it will on the M2. When M2 is on, it means that Y8 is on, and Y8 is on, it means the tank 2 is filled or full. Okay, now X4 is in on condition, it will move toward the 300 value. We can use this value up to 50 or 60, but we have to monitoring purpose we are using it at 300 value. R1 value is 300 here. So it will move towards 60 to 60. Now when it's struck 300, it will on the M2. Yes, it will on the M2, it means the tank 2 is fill. It is shown by Y8, so it is fill out. Now by few usage, it will be used for household or commercial purposes, and we have to now find it, is it empty or not. So we have to stop this. Okay, we have to stop simulation. Yes, we have to stop simulation. Now we have to on the X5. We are going to run it, and we have to now on this X5. So when it is on, so previously we have to off this any other input. Okay, this is on, so we have to off this one and now move toward the this one. So first we off it and then again start it. So first this value must be 300, so we will on it. Okay, when it will move toward the 300, so we have to, for empty we are then using X5. Now it will reach toward the 200 approximately. When it reaches toward the 300, the tank 2 will be filled with water, and it will be shown by indicator Y8. Okay, now it is on, it means the tank is filled, so it's shown by the indicator Y8. Now we have to on X5 and off X4. So deactivate X4 and then it will give you, because it will fill, so the X4 will be off. Now when it will move toward the 0, it will on the M3, and on when these two will be on, it will on the buzzer Y1. So it will decrement the value. It will decrement the value. Now it will reach to 50. When it will equal to 0, now okay, this value, now when it is equal to 0, it will on the M3. When M3 is on, it means the M1 is on, so both of the tank are empty, so it will give you the indication that buzzer will be on because both are empty. So this is the end of part first of lab 10.